Welcome to the Integrated Math 3 Unit 1 review number 2. Today I will be covering questions number 1 through 11 for your test tomorrow. Let's begin. It says, what is the recursive formula for the sequence that is given by the explicit formula a sub n equals negative 4n plus 1? So this is my explicit formula, and they want the recursive formula. So this is an arithmetic sequence. I can tell because there's a common difference of negative 4, right? And there's no common ratio given to me. All right, so the explicit formula, to go from the explicit to the recursive, you do need to know that the recursive is a sub n equals a sub n minus 1 plus d. Again, a sub n equals a sub n minus 1 plus d. And in the recursive formula, the only thing you're substituting in is your value of d. And remember also, just in case it's a multiple choice test, they can use a sub n equals a sub n minus 1 or plus d, or they could use a sub n plus 1 equals a sub n plus d, as long as these two subscripts are one value apart. All right, so when we're identifying d in this formula, d is always the number that is going up or down by our common difference, right? And then this value would actually be our a0, not our a1. It's a0. Again, that's because if this were like y equals mx plus b, y equals mx plus b, m is our amount that we're increasing or decreasing by each time, our slope of the line, which is also d, and this would be our y-intercept, which is also our a0. Okay, so d equals negative 4, so I'm going to substitute that in right here, and I have a sub n equals a sub n minus 1 minus 4. Done. That is the recursive formula. All right, for number 2, it says write the simplified formula that is the representation for the nth partial sum of the series 4 plus 7 plus 10 plus 13. All right, so the partial sum formula, when we have an arithmetic, there's two formulas we can choose from. One of the formulas is s sub n equals n over 2 plus times a1 plus an. All right, the problem is here we don't know an, so we cannot use that formula. So instead, we're going to have to use the formula s sub n equals n over 2 times 2a1 plus n minus 1 times d. So we're going to use this formula instead. And the reason, again, is because we don't know an. We do not know how many terms there are. All right, so we're going to identify our a1. Our a1 is 4. And our common difference, d. Our common difference is positive 3. And I'm going to substitute those values into this formula. So that will give me s sub n equals n over 2 times 2a1. 2 times a1 would be 8, right? 2a1, which would be 2 times 4, that's 8, plus n minus 1 times d, where d is 3. Now, they want it in simplified form. So to simplify this, I will need to distribute this 3 through and combine like terms. So I would have n over 2, and then that would give me 8 plus 3n minus 3. And when I combine like terms, my positive 8 and my negative 3, I will have, I'm going to move down here, I will have s sub n equals n over 2 times, that would be 5 plus 3n, or 3n plus 5. And if they want me to distribute through, I'll have to do one more step. S sub n equals, I'm going to distribute the n over 2. Remember, when you're multiplying fractions to a whole number, you can put a 1 underneath. That would give me 3n squared over 2 plus 5n over 2. And that would be my simplified form. All right, and here's our final answer for the first one as well. Okay, next it says the first row in a theater has 30 seats. All right, that is my A1. So A1 is 30. It says, and every other row has 3 more seats. That means my common difference, D, is increasing by 3. It says, how many seats are in the first 10 rows of the theater? So I need to know the total of the first 10 rows. So I'm not looking for just the 10th row. I'm looking for all 10 rows. So this is a sum formula again. And this is arithmetic, so we can use either this formula or this formula. If you want to use the first one, you're going to have to find an. If you want to use the second one, you will not have to find an. So S sub n equals n over 2. That's 10 over 2. And then 2a1, 2 times a1 is 60, plus n minus 1. N minus 1 is 10, or minus 1, which is 9, times d, which is 3. Again, this is n over 2, 2a1, a1 is 30, so that would be 60, plus n minus 1, which would be 10 minus 1, 9, times d. 10 over 2 is 5. This is 27. 60 plus 27 is 87. 5 times 87, I'll do that off to the side. 5 times 87. That's 5, carry the 3, 5 is 40, 35, 435. So I got 5 times 87 is 435. All right, the next one, number 4. I'm going to just triple check my math because I felt like I got a different answer today on the review. So I'm going to triple check this. So there's 30 seats. 30 times 2 is 60. 9 times 3 is 27. 60 and 27 is 87. 10 over 2 is 5. 5, that's 5 times is 35. Carry the 3, 40, 43. Okay, 435. All right, write the explicit formula for the nth term. So that's the an, right? We're not summing them. The explicit formula for the nth term, and it's a geometric. I can tell it's geometric because it's not going up or down by the same amount every time. So geometric is a1 and then r to the n. Actually, this is r to the n minus 1. Excuse me. All right, so we need to find our common ratio, r. Our common ratio can be found by taking a term, like the second term, and dividing it by the previous term, like the first term. Or you could take the third and divide it by the second, or the fourth and divide it by the third. Regardless, you're going to get the same value, which in this case is 1/4. And so our first term, a1, is 8. So our explicit formula is going to be a1, which is 8, times r is 1/4, to the n minus 1, done. That is our explicit formula for a geometric. All right, next, what is the value of the given sum? All right, they want us to find the sum of the first 5 terms. So from 1 to 5, that means that we're finding the first 5 terms of, this is a geometric again. This is my a1, again, just like here. And this is my r, common ratio of 3. So n is 5, a1 is 2, and r is 3. So to find the sum, S sub n, of a finite geometric, we're going to use the formula S sub n equals a1, 1 minus r to the n over 1 minus r. And we're going to substitute in our values. So S sub 5 equals A1, which is 2, times 1 minus R3 to the 5th power over 1 minus 3. Now, I didn't bring my calculator home, so I'm going to do 3 to the 5th power off to the side. 3 to the 5th is 3 times 3 times 3 times 3 times 3. That is 9 times 9. 9 times 9 times 3, which is, 9 times 9 is 81 times 3, which is 243? 243 is my value here. All right, so I get 2, 1 minus 243 over 1 minus 3. 1 minus 3 is negative 2. 1 minus 243 is 242. So I have negative 242, I'll do this off to the side, divided by negative 2, which is 121. So it's 2 times 121. 2 times 121 is 242. All right. Next, for what restrictions on x will the infinite geometric series converge? All right, so a geometric series, an infinite series will converge if the absolute value of r is less than 1. It will diverge if the absolute value of r is greater than 1. So let me explain what converge versus diverge means. So to converge means that if our value r is, absolute value of r is less than 1, like it's a half or a fourth or even negative 1/2, what will happen is that our sequence is getting smaller and smaller and smaller, like we're cutting it in half every time. And so that value will tend towards a number. It will converge to a number when we sum it up. But to diverge means it's going to go to infinity. Well, if we multiply it by a value greater than 1, like for example 2, and I try to sum those all up, it's growing infinitely, so the sum will eventually also approach infinity. All right, so they could ask you for diverge on the test. They could ask you for converge on the test. So since they said converge, right away, I'm going to get rid of A and C because both of those show larger than a certain value. Now, in this expression, this value, 6x, is my r value. So what has to happen is that r has to be less than absolute value. It has to be less than 1. Well, right now, 6x is my value of r. And they're asking me for what values of x will this be less than 1. So I'm going to put in my top boundary, right? This says x is less than 1/6. This says x is less than 1. But if I put in my top value, which is 1 or 1/6, only one of these will make this statement true. So if I were to substitute in 1 for x, this would give me 6. And 6 is not less than 1. So it cannot be B. But if I were to substitute in 1/6, absolute value of 1 is 1. It will be, if I put in anything smaller than 1/6, then I will get something that is less than 1, so it will be D. So really, you're just thinking to yourself two things. Number one, is it converging or diverging? If it's diverging, it's going to be greater than 1. If it's converging, it has to be less than 1. And then you have to figure out what value of x will make this r be less than 1, which is 1/6. Anything less than 1/6. Okay, flipping it over. Number 7 says find the sum of a convergent geometric series. So we know if it converges, there's a sum for the infinite sequence, and that sum, it's infinite, so it's not s sub n, it's just s equals a1 over 1 minus r. So you must know this formula for a convergent infinite series. Now I know it's infinite because it says ... It keeps going on forever. All right, in this case, a1 is 100, and r. We have to find r. To find r, we take any term like negative 50, and we divide it by the previous term, which is 100. Or you could do that with 25 and negative 50, or negative 25 over 2 and 25. Generally, I pick the first two. This gives me r equals negative 1/2. And I'm going to substitute my value of r and a1 into this formula, which is 100 over 1 minus negative 1/2. 1 minus negative 1/2 is, so this is going to be 100, 1 plus 1/2, which is 1.5. And then 100 divided by 1.5. When you do that on your calculator, you will get 66.6 repeating, or 66.67. All right, number 8. A rectangular box with a square base has a length and width equal to the width, W. So my base is a W by W square. Okay, and it says the sum of the length, width, and height is 20 inches. So the sum, meaning if I add the length plus the width plus the height, I'll get 20 inches. It says, what is the volume of the box in terms of only the width, W? So I know the volume is equal to the length times the width times the height. All right, in this case, they want only W represented here. So I already know I can replace L with W because it says the length and the width are equal. So they're both W. All right, now I need to replace the height with something that has W instead of H. So I'm going to use this second expression that they told me. So remember, the width plus the height is 20, right? The length and the width are equal. So when I combine like terms here, I get 2W plus H equals 20. And again, I'm solving this for H because I want to replace that over here in this formula. So I'm going to get H by itself by subtracting 2W from both sides. So H equals 20 minus 2W. And I'm going to substitute that in right here, 20 minus 2W. This is a W. Right, 20 minus 2W. And if it asks you to simplify, well, that's W squared, and then 20 minus 2W. And then if it asks you to keep going, right, then you would just distribute through again. The volume equals, that would be 20W squared minus 2W cubed, or in standard form, so you might have it written like this, or in standard form, it would be negative 2W cubed, and then plus 20W squared. Either of those are the same. You just have to recognize this is in factored form and this is in standard form. All right, and that is 2W right there. All right, the design of a spherical Christmas ornament is, okay, there's some typos here. First of all, this should be an R squared, and this should be 12 minus 2R. But regardless, and the reason is because this graph will not match this function. Okay, so I'm just correcting the equation. All right, it says, as shown in the graph below, where the radius must be less than 6 centimeters. What is the max volume in centimeters cubed? The max volume happens right here, the top of the graph. And that would be at 60 centimeters cubed. That one's pretty easy, guys. If it says the max volume, you're looking for the absolute maximum of the graph. If you're looking for the min volume, it would be the lowest point. Okay, moving on to number 10. It says sketch the graph of a cubic function with a positive leading coefficient and a y-intercept at -5. So -5, that's right here. There's my y-intercept. A positive cubic. So remember, positive cubic is decreasing to the left and increasing to the right. So it has to be decreasing to the left and increasing to the right. So something that could happen, it could go up through, come back down, turn, and then come back up again. That's a example. Okay, and it says, can you do another one that looks differently? Well, maybe I could, I have to keep my end behavior the same. Maybe I could make it bend down here, come through the y-axis, and then go back up. So it has a different number of roots. Regardless, the end behavior is still of a positive coefficient, and I still have a y-intercept at -5. All right, final one, number 11. It says, describe the end behavior of the graph -5x to the third. It says in nerd language. So what they're talking about is the formal language. For this graph, it is a cubic and it has a negative leading coefficient. So it'll actually be the opposite of the previous problem. It will be increasing to the left and decreasing to the right. And so the language they're looking for is this. As x approaches -infinity, meaning on the left of the graph, right? As x is going to the left, f of x is approaching f of x. So on the left, it's going upward, so +infinity. And as x approaches +infinity, which means on the right-hand side of my graph, f of x, or y, is approaching, it's going downward, so -infinity. All right, I'm going to say that one more time. So this is on the left of my graph. The left would be where x is approaching -infinity. On the left-hand side, y, or f of x, is approaching +infinity. And on the right-hand side, on the right, as x is approaching +infinity, right to the right, y, or f of x, is approaching -infinity. All right, guys, that was your review of the first 11 questions. I hope you watched it. I hope that you studied tonight, and have a great night. I'll be seeing you tomorrow for your test.